Question number 21 says, which of the following are greenhouse gases? First CO2, second CH4, third N2O, or fourth all of these? Dear students, it's a factual question. Few of the greenhouse gases are CO2, CH4, N2O, O3 that is ozone, and chlorofluorocarbons. Therefore, for this question, all of the given options are greenhouse gases, and hence option number 4 is the correct answer. Now let us proceed to the next question. Question number 22 says, heat required to change 20 gram of ice at minus 20 degrees Celsius into steam at 100 degrees Celsius is. The data is given of the specific heat of ice, water, and the latent heat of vaporization of water, as well as the latent heat of fusion of ice. Dear students, to convert 20 gram of ice at minus 20 degrees Celsius into steam at 100 degrees Celsius, the heat required can be written as, if the mass can be written as m into C of ice, that is specific heat of ice, into delta theta. Here delta theta will be minus 20 to 0 degrees Celsius, plus mass into latent heat of fusion of ice, that is LF. This will be due to the phase change in which the temperature remains constant. Further, we can write that m into C of water into delta theta. Here the C of water is the specific heat of water, while delta theta will be from 0 degrees Celsius to the 100 degrees Celsius. And last, we have to add m into LV, where LV is the latent heat of vaporization and m is the mass, that is 20 grams. This will be the transition from water to steam, in which again the temperature remains constant. On substituting the given data, we can find out the value of Q, and this turns out to be equal to 14600 calories, and therefore option number 3 for this question is the correct answer. Now let us discuss question number 23. Question number 23 says, the mean translational kinetic energy per molecule for diatomic gases. It is given that Kb is the Boltzmann constant. Dear students, the mean translational kinetic energy per molecule per degree of freedom is equal to half into Kb into T, where Kb is the Boltzmann constant. This is a factual question, and for this question the option number 2 is the correct answer. Now let us discuss question number 24. Question number 24 says, an ideal gas is undergoing through an adiabatic change. The correct pressure P, temperature T relationship is. Dear students, for an adiabatic process, PV to the power gamma is constant. Substituting V as nRT by P, this will be also constant. And from a little rearrangement, we can write down that P to the power 1 minus gamma, T to the power gamma will be constant, which means that P T to the power gamma divided by 1 minus gamma will be constant. And hence, dear students, option number 2 is the correct answer. Now let us discuss question number 25. Question number 25 says, at 20 degrees Celsius, the value of density of a fixed mass of an ideal gas divided by its pressure is K. At 120 degrees Celsius, this ratio will be equal to. Dear students, from the ideal gas equation, we can write down that PV is equal to nRT, where N is the number of moles. We can further write down that PV will be equal to small m by capital M into RT, where small m is the mass of the gas and capital M is the molar mass. Therefore, we can write that P will be equal to rho RT by M. Dear students, the value of rho by P will be equal to M by RT. And this is the ratio which is being dealt in this particular question. 20 degrees Celsius is equal to 293 Kelvin, while 120 degrees Celsius is equal to 393 Kelvin. We can see that this ratio is actually inversely proportional to temperature. Therefore, the final ratio K dash by K would be equal to, we can substitute the values of temperatures and write down 293 by 393, which means that K dash will be equal to K into 293 by 393. And hence option number 2 is the correct answer. Now let us discuss question number 26.